So far, we've been using a pretty informal definition for what an ellipse is. I've just been saying that an ellipse is kind of a distorted circle, one that's been stretched out either horizontally or vertically. The more formal definition relies on what are called foci of an ellipse. So here's how the definition works, and it's kind of a mouthful at first, so we'll read through it, and then we'll try to digest it and make sense of it. If we're given two fixed points, F1 and F2, in a plane, an ellipse is the set of all points xy, where the distance d1 from F1 to xy added to the distance d2 from F2 to xy remains constant. Now, what that means when you look at this definition, you start with these two focus points. Plural of focus is foci, so F1 and F2. These are what are called foci of an ellipse. So imagine you have two fixed points. If you take any point on the ellipse, no matter what its coordinates are, and you measure these distances, the total distance, d1 plus d2, whatever these two distances add up to, would be constant. So let's say in this picture that you figure out the foci, you measure these distances to any point. Let's say that when you add d1 and d2, you get a total of 10 for the distance. You would get that same total regardless of your location on the ellipse. So if this xy point were actually over here, then if I were to measure these two distances and add them together, I would get the same total of 10 units. Notice this one is a lot shorter, but the other one is much longer, and they would still add to the same total. And that would happen regardless of where you're located on the actual ellipse. Those two distances added together always give you the same constant. And remember, those fixed points, F1 and F2, those are called the foci of the ellipse. Now, I'm going to show you how to calculate the foci and figure out their location. They're always on the major axis, and they're always inside the ellipse. So I'll show you how to calculate their coordinates with our next example. So let me make sure I've got everything in frame here. Move down just a little bit. There we go. So for the ellipse, defined by the equation 25x squared plus 16y squared plus 32y minus 384 equals 0, we want to find the coordinates of the center, the vertices, the foci, and the endpoints of the minor axis. It says, this should say then, sketch the graph. I actually do the graph much earlier on. I think it's easier to get the equation, do the graph, and then I'll worry about finding any of these additional features. So to rewrite the equation, let's go ahead and take a look. I've got the 25x squared. Notice there's no x term, so I'm not going to have to complete the square for that variable. For the y group, however, I've got a 16y squared plus 32y, leave a space, that's going to equal positive 384. Let's go ahead now and focus on this y group. You can factor out a 16 from both terms. So we've got the 25x squared, we're factoring out a 16. That'll leave us with y squared plus 2y, I leave a gap, and it's still equal to 384. Now, to fill this gap, notice cut the y term in half, so that's down to a positive 1. I'm going to jot that down over here to the left. Now I square it, so if I cut it in half, that's 1. I square it, that's still a 1. Now what you got to be careful with, if you add a 1 inside that set of parentheses, that's really adding a total value of 16. So that's what you compensate with over on the right. Now to simplify, we've got 25x squared plus 16 parentheses. This perfect square trinomial would factor as y plus 1 squared, and that's a total of 400 over on the right. Let's go ahead at this point and divide every single term on both sides by 400. Remember, you always have to end up with a 1 on the right-hand side. So we divide everything out by 400. 25 goes into 400 16 times. So that first one is x squared over 16. Plus, here I'm going to have y plus 1 squared. 16 goes into 400 25 times. And this is all equal to 1. Now, a couple of key things right off the bat that we can use in order to graph. Notice the center. This x value isn't adding or subtracting anything, so the center would be at 0 for the x, negative 1 for the y. So go ahead and mark that center point at 0, negative 1. Notice your a value, which is your horizontal radius, is equal to 4. So from that center point, I'm going to count 4 units to the left, 4 units to the right. My b value, which is my vertical radius, is equal to 5. So that's going to be 5 units up and then 5 units down. Notice this is a vertical ellipse because the major axis is vertical. So let's go ahead and sketch this in, and then we'll start looking at all the features they're asking us to find. So there's our graph of our vertical ellipse. So for the ellipse that was given, we found the coordinates of the center. I'm going to cross that off so I know that's done. They asked us to sketch the graph. We did that. Next, we need to identify the vertices, the foci, and the endpoints of the minor axis. All right, so the vertices. The vertices here are just the endpoints of the major axis. So let's jot those down. Your vertices here are going to be at 0, 4, and 0, negative 6. So those are the coordinates of the vertices of the ellipse. Like I said, those are much easier to figure out after you do the graph. So I've got the vertices. I'm going to jump over the foci for now. Let's look for the endpoints of the minor axis. The minor axis is the horizontal. So for the minor endpoints, looks like we have one at 4, negative 1. And we have another one at negative 4, negative 1. So at this point, and I'm going to go ahead and cross off the endpoints. At this point, we've identified the graph and all of the features except the foci. Now I want to show you how you can get the coordinates of those foci with some quick definitions down here at the bottom of the page. So notice it says for an ellipse, a focal chord is a line segment that's perpendicular to the major axis through a focus with endpoints on the ellipse. To actually find the coordinates of a focus point, or the foci, I'm going to show you this foci formula for an ellipse is c squared equals the absolute value of a squared minus b squared. So if you look, you already have the a and the b value. So this, and we know a, that's our horizontal radius, b is our vertical radius. C is the distance from the center to a focus point. In fact, let me jot that down. C is the distance from the center, so from the center to a focus. And of course, it's the same distance to each focus. It doesn't matter which direction you go. They're always on the major axis, and they're always c units from the center. So in this case, let's go ahead and plug in what we know. C squared equals the absolute value of a squared minus b squared. You'll notice why the absolute value is important here. A squared is 16 minus b squared is 25. So do you see why they have the absolute value? We've got to make sure that this c squared number ends up positive. So 16 minus 25, that's negative 9. but since it's in the absolute value bars, we get positive 9. And of course, then just take the square root, you find that C is 3 units. So to find the coordinates of our foci, I'm going to go back to my graph, and from that center point, I'm just going to count 3 units up, and then we're going to move 3 units down. So here's 2, 3 units down. And it doesn't matter which is which, F1 and F2 or vice versa, but notice they're always on the major axis and they are C units from the center point. So these two focus points have coordinates 0, 2, and this one is down at 0, negative 4. So let's go ahead and jot down those results, and then we've got everything listed that they asked us for. So here, the foci, which is plural for focus, the top one had coordinates at 0, 2. The lower one had coordinates at 0, negative 4. And now finally, I can go back to that example set, cross off that last thing they were asking us to find. So that example's complete. If you turn the page, I've got one last example for us to look at, and it kind of puts all of these ideas together. So here it says an ellipse has a foci. That should just say a focus, or it should just say has foci. Sorry for the typo there. So an ellipse has foci at 10, 0 and negative 10, 0 with a minor axis 10 units in length. Here's what they're going to ask us to do. Find the equation of the ellipse in standard form and graph the ellipse and label the foci and the vertices. Now, as always, I like to graph and use the graph to help me figure out some of the information. So I'm going to start right away by looking at the graph down here and just plotting the information that we're given. So they tell us our ellipse has foci at 10, 0 and negative 10, 0. Now notice that's really useful information because it immediately tells me the center of our ellipse is at 0, 0. Right? That's just the midpoint of the two foci. The other thing you can notice is that the minor axis is 10 units in length. These focus points are always on the major axis. So the minor axis is going to be moving up and down, and the minor axis is 10 units long. Well, if the center's at 0, 0, that means I move 5 points up and 5 points down. The only thing left for us to figure out are the vertices. Now the endpoints of this major axis, also known as the vertices, are going to be somewhere outside the focus points. Remember, the focus points are always inside the ellipse. So when you look at the ellipse, it's going to be something like this. So let's start jotting down everything that we've determined so far. We know that our center has coordinates 0, 0. We also know the value, we know the value or the distance from the center to one of these focus points is 10 units. So that distance is called C, and that's 10. We also know this vertical radius is 5 units. So B equals 5. The A, which is the horizontal radius, we don't know. But we have an equation, a little formula, that says C squared is equal to the absolute value of A squared minus B squared. So in this case, C squared, that would be 100, equals A squared, I don't know what that is, minus B squared would be 25. Now if you look, we know that A is longer than B, right? B is 5 units. A is more than 10 units. So I don't need the absolute value bars. This difference has to be positive anyway because A is the larger of the two. So we can do without the absolute value. So 100 equals A squared minus 25. Let's add 25 to both sides. So 125 is equal to A squared. So if you want that A value, if you want to fill that out, that would be the square root of 125. And of course, we could reduce that factors as the square root of 25 times 5, or 5 square root of 5. Now let's write the equation. So if you look, we've got all the key pieces of information. The equation of an ellipse is always x minus h squared over a squared plus y minus k squared over b squared equals 1. Well, this center has coordinates 0, 0. Let me move this up a little bit, make sure I have plenty of room. So the center was at 0, 0. H and k are both 0. So that's just going to be x squared and y squared. We've already determined a squared is 125. B squared, well, b is 5, so b squared is 25, and that's all equal to 1. So here's the equation of our ellipse. And so let's see, that takes care of part A. For part B, we want to graph it and then label the foci and the vertices. Okay, so as far as the graph is concerned, we've already got the center. We've already got the endpoints of the minor axis marked. We just need to go A units left and right from the center. So I'm going to go ahead and type this into my calculator. And I'm going to take the square root of 125. Or you could type in 5 square root of 5. Either way, you're going to get a decimal of 11.2. So from that center point, here's 10. 11.2 would be slightly to its right. And then I'll do the same thing over here on the left. Let's go ahead and draw in this ellipse. All right, this thing has been distorted by being stretched horizontally. The last thing they ask us to do is label the foci and the vertices. So the foci are these points inside. I'm going to label these F1 and F2. Of course, it doesn't matter which is which. The vertices are the endpoints of our major axis. So that's V1 on the left and V2 on the right. At this point, we've identified all the information that they asked us for. So that does it for our discussion in section 4.3. We've learned about the circle and the ellipse. Those are our first two conic sections. When we come back and look at section 4.4, we'll look at the other two, which are the hyperbola and the parabola. So as always, once you complete the video lecture and you complete your notes, go ahead and try the assignment. The assignment's a worksheet posted on Blackboard. And just let me know if you're having any questions. I'd be glad to help.